Now let's talk about problem 2. Uh, for problem 2, we know the joint density function of x and y. And we know the range. Y is more than 1, and x is from 1 over y to y. And first, we can draw the non-zero area. It's like this. So first we can draw 1 over y. The function is like this, and y is this. So both of them go through the point 1, 1. And y is more than 1, so it is over behind this line. This line is 1 equals to 1. So this area is where we found. And this is problem 1. And for problem 2, we can calculate A. So we know that because fy is the joint density function, so we know this formula. For this part, the range of y is from 1 to positive infinity. For x is from 1 over y to y. And so this equals from 1 to infinity, 1 over y to y, a y to the power 2x. And for this part, it is very easy. 1 over x is ln x. So ln x from y to y dy. So we can see ln y minus ln y to the power minus 1 is go there, so it's plus. It equals 2 ln y. So this equals a 1 over a from e to positive infinity. This is 2. This is 2 ln y over y to the power 2 dy. This is 2 because there are 2 times ln y. So now we can make this. We can let ln y equals to u. So ln y equals to u, so y equals to e to the power u. So this part equals to two over a from 0 to infinity u over e to the power 2u deu. So this and this, so it equals 0 to infinity u eu. So it's du. And we can calculate at this. It equals 2 over a from 0 to infinity u d e to the power minus u. It equals u times e to the power minus u from 0 to infinity minus from 0 to infinity e to the power minus u du. That equals 1. And this part equals to 1, minus 1, and this part equals to 0. So a equals to 2. And for problem 3, let us to find the fx and yy. So for we can see this area. So it is more easy for x. So we can calculate fy first. It equals from 1 over y to y. A equals to 2. So x. It equals, we can say it's 1 over 2 multiply y to the power 2, and this part is ln y, 2 times ln y. So it equals ln y over y to the power 2. So for x, we can see that there must be two situations. One is there and one is there. So here is the line. So we can x to two parts. We can distribute, we can divide x into two parts. From 0 to 1, fx equals to, so 0 to 1, it equals to, this one is, this is y equals to 1 over x. So it from 1 over x to infinity. So we can, after calculating, we can get this part, it equals to 1 over 2, 0.5. And for this part, for this part, we can see that the x is from there to there. So this point is y equals to x. So it from x to infinity. After calculating is 2 times x to the power 2. 1 over 2 times to the x power 2. So we get the density function of x and y. And the last question, we must to prove that is valid density function. It is very easy. For fy, we have it equals from 1 to infinity ln y. It's fy means ln y over y to the power 2, and dy, and we can make this part behind. So it equals from 1 to the infinity ln y minus 1 dy to the power minus 1. So it equals minus 1 ln y equals y to the power minus 1 from from 1 to infinity, minus 1 to infinity, minus y to the power minus 1 d ln y. So this part is equals to 0, and this part is from 1 to infinity, the minus 1 and the minus and change to the plus. So y to the power minus 2, it equals minus y to the minus 1. From 1 to the infinity, it equals to 1. So we prove that the density function of y is valid, and we can calculate x. So the x has two parts. For the first part, from 1 to 0, it equals to 1 over 2, and to 1 to infinity, from 1 to infinity, the density function equals to 1 over 2 times x to the power 2. So this part, it equals to 1 over 2 plus this part equals to minus 1 over 2 times x to the power minus 1 from 1 to the positive infinity. This part, it equals to this part equals to minus 1, so the whole part equals to 1 over 2. So 1 over 2 plus 1 over 2, it equals to 1. So we prove the density function of x is valid too.